predictability. The milkman, the paper boy, evening TV. Did I get delivered here? Somebody tell me, please. So words confusing me. Clouds as mean as you've ever seen. Ain't a bird who knows your tune. Then a little voice inside you whispers, don't sell your dreams so soon. Everywhere you look, there's a heart, a hand to hold on to.
Hey everyone, I'm Maddie.
And I'm Charlotte.
And we're instructors with Creative Encounters with Science for the summer of 2020.
We're both engineering students, and today we're going to talk to you about light and optics.
What is light? Light is a kind of energy called electromagnetic radiation, and it's what allows us to see. We can see objects because they either give off light, like the sun or a light bulb, or because light bounces off them, like an apple. Light behaves like a wave, and different colors of light have waves that are all a little different in size. These small differences is what allows us to see different colors, like all the colors of a rainbow. Light travels super fast in one direction, and it's called a ray. Light moves so fast that it can travel from the sun to the earth in only 8 minutes. These rays will travel in a straight line until something bends it. When light hits a mirror, it bounces off the mirror and changes paths, which is called reflection. When light passes through something, like a glass or even your eye, it bends, which is called refraction.
This activity uses a water bottle and a laser to show us reflection in action. If you look closely, you can see the light from the laser in the water stream, and it looks like the light is bending. Let's talk about what's happening.
That was really cool. You can try it yourself at home if you have a water bottle and a laser pointer. But how does it work? What we're seeing is that the light is being reflected inside the water stream. Water is reflective both on the outside and the inside of the water. So when the laser enters the water stream, it's reflected again and again and again, so the light follows the path of the stream and seems to bend. This is pretty cool, right?
Can you think of a time when you've seen refraction in real life? It happens all the time. When light goes from air into water, it refracts. That's why a straw can look like it's disconnected when it's in a glass of water. Let's try a cool trick using refraction.
Whoa. Nice.
Light comes at the glass, it bends towards the center. So light coming from the left side of the glass gets bent, comes through the glass and hits the arrow on the right side. It hits the arrow right there. And when light coming in from the right side hits the glass, it gets bent through the glass this way and hits the left side of the arrow. And that's why our image of the arrow is reversed.
It's so cool.
So let's talk about something that I've always wondered about. Why is the sky blue? Well, sunlight reaches the Earth's atmosphere, which is filled with little particles. Sunlight is white light, which means it has all different colors of light inside of it. And so when this sunlight hits the particles, it gets scattered in all different directions, and all the different colors of the rainbow are going to hit this particle and bounce off in slightly different directions. Blue light travels in short, small waves, so it can bounce between the particles in the sky better than any of the other colors. When we look at the sky, we're seeing the light that is reflected off those particles in the atmosphere. Since blue light is scattered the most, that's the color we see. But what happens at sunset and sunrise? During these times, the sky doesn't look blue. It's usually bright red or orange and other beautiful combinations. At sunset, we see the opposite of what happens during the day to make the sky look blue. While looking at the sunset, we see only the light that wasn't scattered in other directions by particles in the atmosphere. Red light waves pass through the particles in the air without being scattered very much, so they reach our eyes during sunset and sunrise. Fun fact, in a polluted sky, there's even more particles in the air, which helps to scatter the blue light. So sunsets in polluted skies can be extra vibrant.
So you may be wondering, how do our eyes work then? Our eyes consist of many different parts, but today we're going to focus on the iris, which is the colored circle in your eye, the pupil, which is the black circle inside of the colored iris. This is what allows light to enter into your eyes, and the retina, which is at the back of your eyeball and you can't see it. When all of these parts of our eyes work well together, you can see perfectly. If someone has trouble seeing, like if they wear glasses, it's usually because their eyes have trouble focusing the incoming light properly on the retina, meaning they have trouble seeing what's in front of them.
You may have heard of the terms nearsighted and farsighted, especially if you wear glasses or if you know someone who wears glasses. Nearsighted means you can see objects that are really, really close to you, like the words in a book, but you have trouble seeing things that are really far away. Farsighted means you can easily see things that are far away, but not things that are close to you. Glasses help people who have a hard time seeing things, whether they're close or far away, by helping your eye to focus light properly. Since every person's eyes are slightly different, every pair of glasses are slightly different, and prescribed to you by your doctor based on what your eyes need.
What are lenses? Eyeglasses use two different lenses, one for each eye, to help you see. These lenses bend the light so that your eye can focus that light properly. There are two main types of lenses, convex and concave. A convex lens, also called a positive lens, is rounded outwards like that. A convex lens focuses the light by bringing the light rays closer together, which is called convergence. A concave lens, also called a negative lens, is rounded inwards like that. A concave lens spreads the light rays out, which is called divergence. Different lenses are used for different people and are sometimes even combined together to help you see better. These lenses help your eyes to bend light properly and focus it so that you can see. Pretty cool, right? Magnifying glasses are another thing that utilize lenses. Magnifying glasses use convex lenses that bend the ray of the light together, or converge them. This tricks your eye into seeing something bigger than it actually is.
Another thing that uses refraction and reflection is a telescope. A telescope is a tool that astronomers use to see objects that are very far away. Really powerful telescopes can see stars, planets, and comets that are so far away and very, very dim. To do that, they have large mirrors or lenses to gather as much light as possible. The most powerful telescopes are huge, so they can take in as much light as possible. The largest, most powerful telescope is the James Webb Space Telescope, which will be shot into space in a rocket in 2021 to see the most distant galaxies in the universe. How does a telescope work? Well, there are two types of telescopes, refracting and reflecting. Let's start with refracting telescopes, which use lenses. The lens at the end of the telescope bends the light that passes through it, and the eyepiece focuses the light for your eyes. The lenses at the end of the telescope bend the light towards the center until the light comes to what's called a focal point. Then the eyepiece takes the bright light from the focal point and spreads it out, which magnifies it. The small image gets spread out over the retina, which is the back of your eyeball, and so it looks much bigger than it actually is. A reflecting telescope, which uses mirrors, works basically the same way. The mirror collects a lot of light from very distant objects and brings it to the focal point. Then the eyepiece takes that light and spreads it out, magnifying it in your eye. A telescope with a larger mirror or a larger lens can collect more light, which makes a brighter image in your eye. To be able to see things that are even further away, a telescope can use a combination of lenses or a combination of mirrors to increase its magnifying power. Thank you for watching our video. If you liked our content, head over to the Creative Encounters website and check out our Camp in a Box for summer 2020. We are shipping out camp activities right to your house for you to do at home. Or you can check out our virtual game design camp where you get to build your own computer game at home.